In this video, I'm going to cover the basics of algebraic expressions. So, algebraic terms are groupings of numbers and variables, and sometimes those variables are raised to a power. We have a number, a letter, and a little superscript number as well. Now, this number here is called a coefficient. It's a coefficient because it is a number that we're actually multiplying this letter by, but more on that later. This letter itself is called a variable, and a variable is something that can change. So this letter X represents a value, but later on the letter X could represent a different value, and so that's why we call it a variable. And then this little superscript number up here, you've seen those before. They are called a power or an exponent. Now sometimes you'll hear the word algebraic expression, and algebraic expressions are simply statements that include variables, and expressions can often be simplified. Equations have an equal sign, and equations can usually be solved. And the key thing to remember is that the equal sign does not say the answer is. It is actually saying one side is the same as or has the same equivalent value as the other. It's like a balance. Everything on the left of the equal sign has the same value as everything on the right of the equal sign. For example, here we have an equation. It has an equal sign, and it says that 2 plus 4 is equal to 3 plus an unknown variable x. And I'm sure we could all work that out. And we are only able to work out what x is because we have this equal sign and we can solve this equation. And we know that 2 plus 4 is the same as 3 plus 3. They both have the value of 6. Okay, here's another one. We have 6 plus 4, and that is equal to 20 minus an unknown value x. And again, we can solve this. We know that 6 plus 4 has a value of 10. So on the other side of the equal sign, we know that 20 minus something must equal 10 as well. And so we know that that unknown variable is the value 10. Now to cover some conventions in algebra. Conventions simply mean how things are usually done. Now, the first thing to note is that the same variable, or the same letter in other words, can be used in different expressions to represent different values. So here in this first expression, x plus 2 equals 4, the x is representing the number 2. In this expression, x plus 3 equals 6. It's a different expression, so this is a different x, and this time this x is representing the number 3. The same variable cannot be used in the same expression to represent a different value. So we could have two x's in here that are the same value, x plus x equals 6, and they both represent 3, but that x cannot represent two different numbers. For example, here, x plus x equals 7. Well, if these are whole numbers, that cannot be true because there is no number that can be added to itself to equal 7. However, different variables in an expression can have the same value. So x plus y equals 6. Well, x could be 1 and y could be 5. Or x could be 2 and y could be 4. Or x and y could both be 3. They're just different 3's. In multiplication, we generally don't show the multiplication sign if we don't have to. In maths, we like to keep everything as short as possible, and so when doing algebra, we treat multiplication as the default sign that we're using. So instead, we just write whatever we are multiplying next to each other. Here, instead of an a times b, I simply write ab. In between the two, we have an implied multiplication sign, but we don't show it. This is also the case when we use brackets here. Later on you'll see expressions that look like this. And this simply means 5 times everything in the brackets because they're up next to each other. Now we wouldn't do the same thing when dealing with numbers such as 2 times 6 and rewrite that as 26. So numbers are a different case. We need to show that multiplication sign between two numbers. The only way you could get around that is by using brackets and put a 2 next to a 6 in brackets, because being up next to the brackets like that implies that we are multiplying everything in those brackets. In division, we generally write division like a fraction. So instead of 4 divided by y, we would write 4 over y. This is done because later on it's actually a lot easier to work with division as a fraction. Here's a tricky example. I have an x plus 2 in brackets divided by 6. Well, that just means we write x plus 2 as the numerator and 6 as the denominator. So here's an example of how we can simplify an algebra. If I have 2 times a, well, that simply means that I have 2a. We imply multiplication when we put the number and the letter up next to each other. Here we have b times c. Well, we can rewrite that as bc. Here I have 1 times d. Now, when we do multiplication, it's kind of like it's shorthand for addition. See, if I go back up to the top here, I have 2 times a. Well, that's the same as writing a plus a. And so I have 2 a's, and there we get 2a. Here, 1 times d is kind of like just saying, well, I have a d. So I don't write 1d with the implied multiplication like that. I can simply write d. Okay, whenever it's 1 times something, whenever we have one of it, we can just write the letter without any number. Here I have an e plus another e. Well, if I count how many I have altogether, I have 3. So I can rewrite that as 3e. Now here I have an f plus an f. And if I do BEDMAS, I'm going to do them first in the bracket. So I could rewrite this as 2f inside my brackets times g. Now, if everything in my brackets is multiplying with the letter on the outside here, I actually end up with 2fg. 2 times f times g.